All right, we are ready for lesson 12 of unit 3. This is solving fraction number stories. We're going to be able to identify problem solving strategies and solve a variety of fraction number stories, apply and extend our previous understandings of multiplication and division, and continue using those equivalent fractions. We're going to use them as a strategy to add and subtract. As usual, let's start off with our warm up. For each one, I want you to estimate the sum by naming the closest benchmark. This is something that we've been doing. So let's look at the first one only. 1/4 plus 5/8. Take a moment and estimate what you think the sum would be. So remember, it can be close to one of those benchmarks. 0, 1/2, 1, 1.5, and so on. So 1/4 we know is close to, it's somewhere between 0 and 1/2. 5/8 is close to 1/2. It's a little over 1/2. So if we put those both together, I would say the estimate would be 1. It would be close to 1. 1/6 plus 1 and 7/8. Look at that. We've got something that's close to 0, so it's a little bit over. And then we've got something that's really close to 2. So if we add those two together, we should get an estimate of 2. And 1 and 1/8 plus 1 and 1 and 1/8 plus 1/10, just 1/10. We know this one is close to 1. This one is close to 0. So our estimate could be somewhere between 1 and 1.5. That could be your estimate. Remember that it can be an estimate. You can say it can be between two benchmarks that you're used to. What is the purpose of estimating the sum? It's to make sure our answers are logical and make sense. So we're going to look at student reference book, page 30. You do not need to pause the computer or your screen to go onto the student reference book. You can, but it's not needed because I have it on these slides. We're going to look at page 30. That's a problem-solving diagram. And as we're doing this, I want you to think about your own problem-solving habits. So when you're working with number stories, what kind of questions do you ask yourself when you're solving a problem? What strategies are you using that you keep doing when you are solving a problem or when it is challenging? This is personal. So we're going to look at it and stop and ask yourselves these questions. Which path do you use? What do you typically do? So you'll see on page 30, it says the following, a problem-solving diagram. When you solve problems, you work to make sense of the problem. You reflect on your thinking and keep trying when the problem is hard. As a good problem solver, you always check to see whether your answer makes sense by trying to solve the problem in more than one way and by comparing the strategies you use to those others use. The diagram below can help you think about problem solving. The boxes in the diagram show the type of things you do when you use mathematical practices to solve problems. The arrows show that you don't always do things in the same order. So taking a look at that, this is the problem-solving diagram. Take a minute to look through that. And again, it said, when we look back at this, you don't always do things in the same order. So the arrows show us that we could start at any one of these and move in different directions. So if you start with understanding the problem, you might do these things that are listed here. And feel free to pause the video at any time or also go on to the Everyday Math site and open up that student reference book, page 30. You might do these things that are listed under understanding the problem, retelling it, figuring it out, figuring out what you already know, imagining what it looks like. And then from there, maybe you play around with the information. And then after you've drawn a picture or write a number model, maybe you then organize it, you study it. And then you go back and you Retell the problem in your own words. It's okay to revisit one of these sections more than once. And then maybe you go down here and you figure out what math can help you. And then you play around with the information again. And then you check your answer as you work. And then you go back and organize it some more. Notice that you can move freely throughout all these steps. It just depends on what you personally like to do. And it might depend on the actual problem itself. So some questions and strategies that you might ask yourself are, what do I know? What do I need to find out? Can I draw a picture of the problem? Can I write a number model? What information is the problem giving me? Do I have all the information I need? Or do I need to find more information? Or is there information that I can ignore? Are they giving me more information than is needed for that problem? What math can help you? Is there a problem like this one that you've solved before? Here are some more. Can I use fraction circle pieces, number lines, any other tools that have been provided to me? So think about that everyday math e-toolkit. Can I use those things that are in there? Will using an estimate help? Using those benchmarks. Can I organize the information? Can I make a list? Can I make some spots that take the information and put it into categories? Play around with the information. Okay, this isn't a question. This is the organizing in this one. These are strategies. Try solving one part first and then moving backwards. You can make a written record. So I know that we have talked about this in room 31 when talking about cubes. We could, on the E, the evaluating, we can make a list, a plan, write out a plan of what you are going to do. And you can also do that as you actually do it. Over to the side, write down your steps. That way, once you get to the end, you can look back and see, okay, where can I go back and check it again? What did I do for this problem? Create a model. And remember, models are anything. Drawing a picture, writing a number model, making a graph, a diagram. A model is anything that involves those. Think about how your model is helping you solve the problem. And I've talked about this before. Sometimes drawing a picture is the best route. Sometimes writing a number model is the best route, or making a graph. This can change depending on your story, your number story, your math problem. And if that one didn't help, try one of the other ones. Talking with other people to work out the problem is often something that can be successful with your strategy. Again, if that is allowed when you're working on the number stories. We all know that there are situations where the number story you're working on has to be independent. But if it's not, talk with other people. And then look back at what you've tried and doesn't make sense. That's where making that list of what you've done really comes in to help. So we're going to apply all of that, and we're going to apply everything you've learned about fractions to solve a variety of real world fraction problems. So here's a problem that we can do as a practice. Okay, Adeline is mixing fruit juice to make punch. She mixes 1.5 gallons of apple juice with 1.5 gallons of grape juice. How much fruit punch will she have? I want you to pause the video and try this out on your own. Ask yourself, what strategy am I going to use? Am I going to draw pictures? Am I going to write a number story? Am I going to make a list? Then you need to determine the math that you're going to solve. Okay? So all I want you to do right now, I don't even want you to solve the problem. I want you to decide, what strategy am I going to use? And you need to determine what math you're going to need in order to solve this. Am I going to multiply? Am I going to divide? Am I going to subtract? Am I going to add? Is it a multi-part problem? Okay, pause the video, think about it. All right, so you can see my thinking here. I have created a number model. I have used cubes. I circled 1.5 gallons of apple juice. I circled 1.5 gallons of grape juice. I boxed in the words mixing and mixes because I know that tells me what I'm going to do. I've underlined how much fruit punch will she have. So I've circled, I've underlined, I've boxed in. I'm now evaluating, right? So up here in my notes, you can see that I wrote the word mix and I put equals add because I know when I'm mixing something together, I'm putting the two together. I'm adding them together. And so then I rewrote 1.5 apple juice mixed with or added to 1.5 gallons of grape juice. I got equal the total juice. So I have picked a strategy and I figured out the math I will need to solve was addition for this one. So here are some other strategies. I showed you mine. Another strategy would be using the red fraction circle to representing 1 whole gallon of juice, and to show 1.5 gallons, they were using a 1 red circle and 1 pink half circle, and then showing 1.5 gallons of grape juice, use the same thing, a red circle and a half, combining the two. They went ahead and solved it. The 2 red circles and then 2 pink halves together represent 3 gallons. The next one was just like what I did. If I would have continued to solve it, I would have seen 1.5 and 1.5. 1 plus 1 was 2. 2 halves is 1. Combining 2 plus 1, we still would have gotten 3. Notice 2 different strategies got us to the same answer. So, what problem-solving strategies and questions did you use from our list we discussed earlier? Answer that to yourself. What'd you do? Hopefully, maybe you thought about what you knew. Maybe you knew Adeline used 1.5 gallons of each. So then you thought about what maybe you had to find. You had to find how many gallons there in all. That's what I did. You could have thought about what math you could use, knowing that you put together 1.5 gallons of one kind of juice and 1.5 gallons of the other. Again, I did that as well on top of the first strategy. Using the fraction circle pieces as a tool, that's something that I did not do. I chose not to, but you could have. And hopefully if that helps you, you're doing that. Okay? Think about how they help you put halves together. So after seeing that, after that strategy, I want you to complete Math Journal page 101, 102, and you're going to have several problems. I think there's 8 of them. So you'll have a number story. And again, remember, you can use those fraction circle pieces, make number lines, pictures, any tools that we've been practicing or any kind of model, use that to help you show your work. Number 1 is about 4 friends sharing 5 sandwiches after their hike. If they each ate an equal share, how many sandwiches did each friend eat? Number 2, Josh combined a half a carton of eggs with 1/3 carton eggs. He said, now I have 2/5 of a carton. Is he correct? Remember going through those strategies. Ryan lives 3 1/4 miles from school. Kayla lives 2 3/4 miles from school. How much further from school does Ryan live than Kayla? Number 4, Delilah was playing fraction capture. She wrote her initials on a 1/3 section and a 1/6 section. What is the sum of the sections she initialed? So even if you've never played fraction capture, you still can figure out what this is asking you to do. 5 and 6, 5 and 6, Lauren had 3/4 a gallon of paint. She poured in an additional 1/8 gallon from another can. How much paint does Lauren have? Number 6, Corion, I don't know, am I saying that right? Is cutting fabric for a quilt. And she has 4 feet of cloth to make 12 quilt pieces. If she uses all the fabric, how long will each quilt piece be? So she's got 4 feet of cloth to make 12 quilt pieces. And 7 and 8, Alyssa started with 7/8 of a jar of jam. She used about 1/6 of the jam to make a sandwich. Alyssa said, I don't need to put the jam on the grocery list yet. We still have about 3/4 of a jar. Is she correct? And then finally, number 8, Tyrell and his mom went grocery shopping. They bought 1/6 pounds of carrots and 2 5/6 pounds of potatoes. Tyrell carried the carrots and potatoes in one grocery bag. How heavy was that bag? So when you're ready, pause and use this to help you solve those problems. Think about the strategies that we talked about and the questions you can ask yourself. Those can be found on this too. Remember page 30 in the reference book, whether you've got a hard copy or you can find it on the Everyday Math site. Pause it, try those out. There's 8 problems, so it should take you a little while to go through all these steps, and then come back and check your work. We'll start with 1 and 2. Their sample work was a picture. Again, you didn't have to do that. They also did 5 divided by 4 equals 5/4 or 1 1/4. So they said that each friend ate 5/4 of a sandwich, or they ate 1 1/4 sandwiches. Number 2, they said the answer is no, Josh is not correct. Here's a sample of how you would explain it. You know that 1/2 and 1/3 should be more than 1/2. When we use the fraction circle pieces, you can see that 2/5 pieces are less than 1/2 piece. So maybe you didn't do the fraction circle piece. Maybe you estimated. Maybe you actually did the math. Okay? It's whatever strategy you did. Number 3, you see they drew out some circles, but they also wrote 3 1/4 minus 2 3/4 equals 2/4. You could also say 1/2. Says Ryan lived 2/4 miles further from school than Kayla. And you can see that there's that 1, 2. Number 4, they just did some addition of fractions there. You can see that they were doing 1/3 plus 1/6, so they created some equivalent fractions. They turned 1/3 into 2/6 so that they both had a denominator of 6 and got 3/6. You could also say 1/2 if you wanted to reduce that. So the sum of the lattice sections is 3/6. For number 5, they did the same thing as in number 4. They created a common denominator of 8, and they added 6/8 plus 1/8, and they came out, she has 7/8 gallons of paint. And number 6, they created a number line, 0 to 4 feet. They took 4 divided by 12, and they got 1/3. Each quilt piece should be 4/12 or 1/3. One thing that I want to point out for this one is ones like these, I took 4 feet of cloth divided by 12 feet. If you remember that, that gave us that fraction, and then you could reduce it. So they also divided it here, so you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we know that we're just talking about one piece and one piece out of 4, or out of 3, sorry, 1/3. And finally, 7, the answer would be yes, and a sample of explanation would be, I know that 6/8 is the same as 3/4. If Alyssa had 7/8 of the jar and used 1/16 of it, she still has more than 6/8. So she has plenty of jam. And finally, number 8, they drew a picture with the circles. They also wrote 1 1/6 plus 2 5/6 equals 3 6/6 or 4. So the bag would weigh 4 pounds. This is where we are finished with lesson 12. Again, remember the big part was identifying those problem-solving strategies. If you ever need it, it's on page 30 in your student reference book.